It's the very first thing we look for when we open our eyes. It wakes you up, pulling the world out of the shadows. It paints every color you've ever loved, the deep blue of the ocean, the burning orange of a desert sunset, the way it dances through a forest canopy. But what if I told you that what you see is only the surface? Beyond the glow, light is the ultimate messenger. It's the invisible architect of our modern world. It travels at a staggering 186,000 miles per second, a cosmic speed limit that nothing in the universe can break. It's not just brightness, it's the key that unlocked the secrets of the cosmos, from the birth of distant stars to the code inside your DNA. Every text you send, every like on your screen, and even the precision lasers that save lives in surgery, they all ride on these silent, shimmering beams. Today, we're going on a journey through the incredible, almost impossible story of light. We're going to peel back the layers of reality, and I promise you, by the time we're done, you'll never look at a sunbeam or the stars above the same way again.
Thousands of years ago, we didn't just live under the sun, we were obsessed by it. The Egyptians worshipped its power, and the Greeks argued over its nature. But for centuries, we had it backward. Most thought our eyes sent out invisible fire or rays to touch the world around us. Then came a man who would change everything. Al-Haytham, known to history as Alhazen. While imprisoned in Egypt, he didn't just think about light, he deconstructed it. He wrote the Book of Optics, a masterpiece that would become the foundation of modern science. Alhazen proved that light travels in perfectly straight lines. He showed us how lenses bend it and how mirrors bounce it back. But his greatest breakthrough? He realized that we don't reach out to see the world comes to us. Light reflects off every surface and enters our eyes, carrying the entire universe with it. It sounds simple today, but back then it was a revolution. This one insight didn't just explain vision, it paved the way for every telescope searching the stars, every microscope fighting disease, and every camera lens capturing a memory. Over 1,000 years later, we are still looking through the windows he opened.
Fast forward to the 17th century. Enter Sir Isaac Newton. Most people know him for the apple and gravity, but his obsession with light was just as revolutionary. In a dark room, Newton performed an experiment that would shatter our understanding of reality forever. He passed white light through a glass prism and watched it fan out into a magnificent rainbow, the visible spectrum. Before Newton, people thought the glass itself was staining the light, but Newton proved them wrong. He took a second prism, turned it upside down, and merged those colors back into a single beam of pure white light. The conclusion was mind-blowing. White light isn't pure. It's a chaotic, beautiful mixture of every color we can see. But then, things got weird. Newton proposed the corpuscular theory, suggesting light was made of corpuscles, tiny, high-speed bullets. For a while, the world agreed. But later, scientists discovered light behaved like a wave, rippling through space like a stone thrown into a pond. This sparked one of the greatest debates in the history of science. Is light a particle or is it a wave? Centuries later, we found the shocking answer. It's both. This is the wave-particle duality. Light is a photon, a particle of energy that travels in waves. It's a cosmic shapeshifter, literally breaking the either-or rules of the universe right in front of our eyes. It exists in two states at once, defying our logic. It makes you wonder, If the very thing that allows us to see the world is itself a mystery we can barely wrap our minds around, what else is hidden in plain sight?
Newton gave us the rainbow, but he didn't realize he was only looking through a tiny keyhole. In 1800, William Herschel placed a thermometer just beyond the red end of the spectrum and found heat. He had discovered infrared. Soon after, we found ultraviolet on the other side. Today, we know that visible light is just one tiny octave in a massive cosmic symphony called the electromagnetic spectrum. It's a vast ocean of waves, ranging from radio waves, miles long, to gamma rays, smaller than the nucleus of an atom. Every second, you are being bathed in invisible light. Your Wi-Fi uses microwaves, your remote uses infrared, and your doctor uses X-rays. We are essentially blind to 99% of the reality around us. We are living in a world of invisible colors that our eyes were never designed to see, yet our technology has finally learned to harness.
As we moved into the 19th and 20th centuries, the mystery deepened. A brilliant mind named James Clerk Maxwell realized something world-changing. Light isn't just a beam, it's a ripple in the very fabric of the universe. He discovered that light is an electromagnetic wave, a silent dance between electricity and magnetism, vibrating through the vacuum of space at impossible speeds. But it was Albert Einstein who truly broke the mold. He looked at the way light hits a surface and realized it doesn't just shine, it delivers a physical punch. This is the photoelectric effect. Einstein proved that light arrives in tiny concentrated packets of energy called photons. When these photons strike a metal surface, they knock electrons loose, literally transforming sunlight into a flow of electricity. Think about the sheer genius of that. Every solar panel on every roof is a tribute to Einstein's discovery. We are literally harvesting the packets of energy that traveled 93 million miles from the sun just to power our phones and light our homes. It's physics, but it feels like a miracle. And then things got truly weird. In the quantum realm, light defies everything we thought we knew about reality. We discovered quantum entanglement, where two light particles can become linked across vast distances. Change one, and its twin reacts instantly, miles or even light years away. No delay, no signal, just a ghostly connection that Einstein himself called spooky action at a distance. In this world, light can exist in two places at the same time. It can be a wave, it can be a particle, or it can be a phantom in the machine. It's a reality that challenges our very definition of what is possible. We are looking at a system so complex, so finely tuned, that it feels less like a coincidence and more like a masterpiece. Light doesn't just power our gadgets, it is the fuel for life itself. Through a process of pure biological alchemy called photosynthesis, plants capture the energy of photons to split water molecules and build sugar. Inside the chloroplasts, a green pigment called chlorophyll acts like a microscopic solar antenna. When a photon strikes a leaf, it kicks an electron into a higher energy state, starting a chain reaction that transforms electromagnetic energy into chemical energy. Every breath of oxygen you take is a byproduct of this light-driven machine. Every calorie of food you've ever eaten is essentially stored sunlight. We aren't just living under the sun, we are walking, talking containers of solar energy. Without the specific, fine-tuned interaction between photons and the chemistry of life, Earth would be as sterile and silent as a graveyard. For centuries, light was a wild force we could never truly corral. That changed in 1960 when an American physicist named Theodore Maiman did the unthinkable. Using a synthetic ruby crystal and a high-intensity flash lamp, he fired the world's first functional laser. He didn't just make light, he forced it into submission. How does it work? It's a process called population inversion. Inside the laser, we pump atoms with energy until they're excited. When one atom releases a photon, it triggers a chain reaction, causing billions of other photons to follow suit in perfect synchronization. By bouncing this light between two mirrors, one solid, one partially silvered, we create a beam of light so concentrated it can travel to the moon and back without spreading more than a few feet. In our factories, light has replaced the saw and the torch. Industrial lasers can weld heavy steel plates for cars and aircraft with a heat more intense than the surface of the sun, all while maintaining the precision of a jeweler. It's a clean power, shaping the machines of our modern world without ever physically touching them. But the real magic happens at the microscopic level. Every smartphone in your pocket and every computer in your home exists because of photolithography. We use ultra-short wavelength lasers to print billions of transistors onto silicon wafers. We are literally using beams of light as the pens to write the blueprints of modern intelligence. Without the laser, the digital age simply wouldn't exist. From the barcode scanner at your local grocery store to the deepest reaches of space exploration, the laser is our ultimate tool. We have taken the weightless photon and turned it into the world's most versatile hammer, scalpel, and pen. We didn't just discover light, we mastered it.
Now, let's talk about the invisible backbone of our civilization, the internet. Most people think their data lives in the cloud, but in reality, it lives in the dark. It lives in a massive global web of glass strands, fiber optics, stretching across continents and buried deep beneath the crushing pressure of the oceans. This is possible thanks to a phenomenon called total internal reflection. In the 1960s, physicist Charles Cow realized that if you made glass pure enough, light could travel for miles without losing its strength. Inside these cables, each one thinner than a human hair, light doesn't just travel, it's trapped in a continuous, high-speed zigzag, carrying data with virtually zero interference. Every high-def video you stream, every encrypted message, every split-second stock trade, it all rides on pulses of light flashing billions of times per second. These photons race at nearly 300,000 kilometers per second, carrying the collective sum of human knowledge across the planet in the blink of an eye. Without this mastery of light, our modern world would simply go dark. No streaming, no global commerce, no instant connection to the people we love. We have effectively turned the planet into a single, giant, thinking organism, connected by nerves made of glass and powered by the speed of light. It is the ultimate triumph of human ingenuity, taking the oldest thing in the universe and using it to build the future.
Light is not done shocking us. In the world of medicine, we've moved beyond the X-ray. We are now using photodynamic therapy, where light-sensitive drugs are injected into the body and activated by specific wavelengths of light to destroy cancer cells with surgical precision, leaving healthy tissue untouched. We are literally using photons to hunt down disease at the molecular level. In technology, we are hitting the limits of electricity. Electrons are slow and they get hot. The solution? Photonic computing. We are building processors that use light instead of electricity to move data. These chips are 1,000 times faster and consume a fraction of the power. It's the birth of a new era where light doesn't just carry information, it thinks for us. And forget Wi-Fi, the future is Li-Fi. By flickering the LED bulbs in your ceiling billions of times per second, we can transmit data through the very light that illuminates your room. It's faster, more secure, and it's everywhere. We are turning every light bulb into a high-speed gateway to the sum of human knowledge. In energy, we are finally learning to catch what the sun has been throwing at us for eons. We are developing transparent solar windows and paint that can empower entire skyscrapers. We are moving toward a world where energy is no longer something we dig out of the ground, but something we harvest from the sky. We've spent thousands of years trying to understand the light. Now, we are using it to rewrite the rules of reality. From healing the sick to powering our planet and connecting our minds, we are only beginning to scratch the surface of what this magnificent force can do.
But light's most mind-bending property is its role as a cosmic time machine. Because light travels at a finite speed, exactly 299,792,458 meters per second, everything you see is a ghost from the past. When you look at the moon, you're seeing it as it was 1.3 seconds ago. The sun, you're seeing it as it was 8 minutes ago. This means the deeper we look into space, the further we look back in time. With telescopes like the James Webb, we are catching light that has been traveling for 13.5 billion years, photons that began their journey when the very first stars were born. Light is the only thing in the universe that can bridge the gap between now and the beginning of everything. It carries the blueprints of the early universe across the vacuum of space, frozen in time, until it finally hits our lens. We don't just see the stars, we see history itself, written in beams of light.
So, the next time you flick a switch or stop to look at a sunset, take a moment. Remember that light is not just a utility, it is the very architect of our reality. It is the silent, secret force that built our technology, saved our lives in hospitals, and gave birth to our civilization. It wakes us, it heals us, and it connects us. One day, it may even be the vessel that carries us beyond the stars, into the great unknown. We live in the age of light, and in many ways, the story of light is the story of us. But as we peel back these layers of physics and math, as we witness the sheer precision of every photon and the perfect balance of every wave, a deeper mystery remains. When you look at the vastness of this design, the way it all fits together so flawlessly, does it not make you wonder, who is the mind, the creator behind such infinite greatness?